Let's take a look at exercise 5 here in this worksheet. And we want to begin by deciding on a variable to eliminate. And I'm going to choose to eliminate z. You can start with no one variable seems significantly easier than the other. It does not matter if you eliminate x, y, or z first. Generally, the only thing guiding you should be which variable is easiest to eliminate first. That would be your choice that you would want to make. I'm going to use equation A, and I'm going to use B to eliminate z. And again, I want opposites on the coefficients. So I see that I have a 9, so I'm focusing on the z terms. I have a 9z in equation A, a 12z in equation B. So I'm going to multiply equation A by -4. That'll give me a -36z. In equation B by 3, that'll give me a +36z in that equation. So every term in A gets multiplied by -4. And then every term in equation B gets multiplied by +3. And I notice when I do that every term on both sides of the equation cancels out. So I'm left with 0 equals 0, which is a true statement. And the only thing I can say at this point is that the system might be dependent. I can't make a conclusion at all because I haven't used the third equation. I've only used 2 of the 3 equations. In order to conclude that the system is dependent, I have to use all 3 equations. So all I know is that equation A, since all terms canceled out, that means equations A and B represent the same plane. So these are really equivalent equations. If I were to graph equation A, I would get the same plane that I would obtain if I graphed equation B. So given that, I'm going to seek to eliminate z again. And this time, I have to use C. And I'm going to use A and C. You just as well could have used B and C. And I notice that z in equation A is 9z, and the z term in equation C is 15z. So if I multiply equation A by -5, I'll get a -45z. And if I multiply equation C by 3, I'll get +45z. So I'll get the opposites that I desire. And I focus on one variable, even though it may turn out that more than one variable is eliminated. To do what I decide to do, I focus on one variable. And since I already eliminated z using A and B, I want to focus on eliminating z again involving C. And I could have either used A and C or B and C. So -5 times equation A gives me -60x minus 75y minus 45z equals -120. 3 times equation C gives me 60x plus 75y plus 45z equal +120. So I see then that, again, every term cancels out on both the left and right side, and I get the true equation 0 equals 0. So this is the situation where the system is indeed dependent. All three equations, because I got 0 equals 0 when I worked with both pairs of two equations, and that work involved all three equations, then I know that this is a situation where all three equations represent the same plane. So the solution set is the set of all x, y, z such that, and I can use any one of the equations. So I'm going to just use A, 12x plus 15y plus 9z equal 24. So in other words, whatever x, y, and z I choose has to make that equation true. So I can basically pick two of the variables, and the third one will be determined by this equation. I have total freedom on two of the variables, and the third one will be determined. And on this type of problem, my math lab I believe, just tells you to choose the system is dependent. There are infinitely many solutions. I don't even think on this type it looks for a description of the solutions. Okay, so that is problem 5. Let's take a look at problem 6. So there are infinitely many solutions would be the answer choice on a problem like that. Here's another example where we want to solve the system, and if the system is dependent or inconsistent, we want to say so. If it's dependent and it's possible to do so, we want to express the solution set in terms of z. So let's begin our work here. I'm going to choose to eliminate x first. All right, I'm going to use A and B to do this. So I see that if I'm focusing on x, if I have a 9x in equation A and negative 3x in B, so if I add A to 3B, I'll eliminate the x terms. So to figure out what I need to do, I focus on one variable only. It doesn't matter if I wind up eliminating more than that variable, but my focus is to just look at one variable. And if I seek to eliminate that and other variables get eliminated, no problem. And I can see that it does happen in this case that every term on both sides cancel out when I add the two equations together. So I get the true equation 0 equals 0. So all I can say is that the system might be dependent. That's all I can say. Okay, so now I've got to use the equation C before I can make a conclusion. So I'm going to use B and C. And I'm still focusing on elimination of x. So I notice that I have a negative 3x in equation B and a 7x in equation C. So if I multiply equation B by 7, I'll have negative 21x in B. And if I add to that 3 times C, I'll have a 21x in C. So I'll have the opposites that I want on my x terms. So a negative 21x results when I do 7 times equation B, and a positive 21x results when I multiply equation C by 3. And so I focus only on that, and then I go ahead and do the rest of the work. All right, and I see what happens in this case is that on the left side, every term cancels out, leaving me with a 0 on the left side. But on the right side, I get a negative 12. So I get this false equation. The variables have dropped out of my work, and I get the false equation 0 equals negative 12. Whenever this type of equation arises, even if I've only used 2 of the equations, I can automatically conclude without doing any more work that the system is inconsistent. That means there are no solutions. And notice, at first it looked like I might get a dependent system, but I couldn't tell whether that was going to happen or not until I involved equation C. And I see that equations A and B represent the same plane. Equation C is a plane parallel to the plane that A and B represent. So parallel planes never are going to intersect. So the overall conclusion here is that the system is inconsistent. My math lab will basically just want you to say there are no solutions. However, if a problem like this shows up on your exam, I'm looking for you, as the instructions indicate, to state that the system is inconsistent, and then also to state that there are no solutions. So that's what happens in this case. 2 of the plane equations represent one plane. The third equation represents a plane that's parallel to that one plane. So there's never a point that will lie on all 3 planes. So there are no solutions.